All right, folks, so today we're going to be talking about rules that we use when we are doing operations with bases and exponents. So first, a little review. If I have x squared, which we saw a whole bunch in the last unit because that was our quadratic, then what do I call x? X is the base, and then the 2 is the power, or another word for that is the exponent. So these are the parts of what we are going to be learning rules for today. So as you can see, in all of these problems, I have a base, and then I also have a power or an exponent. So folks, we have the mnemonic device PEMDAS that helps us with order of operations. For our bases and exponents, we are going to have a different mnemonic device, and that is mad spam. Say it with me. Mad spam, mad spam, mad spam. What does it mean? I don't know. What does PEMDAS mean? Mad spam is just a word that we use to describe what we are going to be doing with these exponents. So it's not only important to know the word, but also how to write it. So it's M to the A, D to the S, and P to the M. And I want you to go ahead and put parentheses around the P. And what this device shows us visually is the base operations. Those are the capital letters. And then the power operations. So as we start working through these problems, MATSPAM is going to help us figure out what to do with the powers based on the operation between the bases. If we are multiplying the bases, we add the exponents. If I'm dividing the bases, we subtract the exponents. Now the P stands for powering up. Powering up. But you'll notice that I put parentheses around it because that's going to be an indication of that base operation as well. Mad spam. As a little caveat to division, I want you to put a note that says resolve negatives first. Resolve negatives first. And we will see that in action once we start working through some of these problems. So in this first problem, we've got x to the m times x to the n. My operation between the bases is multiplication. So if I'm multiplying the bases, what are we going to do with the exponents? Add them. So this would be x to the m plus n. So this corresponds to the MA part of MATSPAM. Now, I don't know about you, but I really don't like those examples that have all variables in them. So we're going to see what this looks like using some actual numbers. So let's try x squared times x cubed. So if I had x squared times x cubed, I could expand that to be x times x times x times x times x. How many times am I multiplying that x times itself? 5 times. So this MA part of MATSPAM is a shortcut so that instead of having to write out the expansion for how many x's we're multiplying together, we can just straight up add those two numbers together. Now it does get a little confusing because I am multiplying these together, but my shortcut allows me to add the exponents to find out the total number of x's we are multiplying together. So our base operation is multiplying, the power operation is adding. Let's go ahead and take a look at, we're going to go down to this one, this fraction one. This is the D to the S part of MATSPAM. This says if I am dividing the bases, I've got x divided by x, then I'm going to subtract the exponents. And I want you to put a note that says top minus bottom. So the top power minus the bottom power. So that would give us x to the m minus n. So let's see what this one would look like with actual numbers. Let's say I've got x to the 5th over x to the 3rd. If I were to expand this out, I would have x times x times x times x times x over x times x times x. Now you may remember doing problems like this back in middle school where can I cancel out those x's? Yeah, because x divided by x is just 1. So these I can cancel, these I can cancel, and these I can cancel. So what I'm left with is x squared. And as we can see, our shortcut here says if I am dividing the bases, we can subtract the exponents, and 5 minus 3 does indeed give us 2. So my base operation is dividing, but what I can do with the powers or the exponents is subtract them. How are we doing so far? So math-wise, it's pretty easy. We're really just like adding, subtracting, and multiplying. But conceptual-wise and keeping track of when to do what, that's what can make this a little bit more challenging. So we're going to move to some of these other ones now. This one would be an example of p to the m. We are powering up the base, so we are going to multiply the exponents. So if I have x to the m raised to the n, we're going to multiply those, which gives me x to the m n. Now an example of this would be if I had x squared cubed. If I were to cube x squared, I would have x squared times another x squared times another x squared, or x squared times x squared times x squared. And if I expand all those out, how many times am I multiplying x times itself? 6 times. So this is where the multiplication part comes into play. So it's a shortcut, MadSpam is, so that I don't have to do the full expansions every single time. Now, moving on to this one, it is also powering up. Now, when I power up, we are going to multiply all of the exponents by m. Folks, how many exponents do I have inside this parenthesis? There are 2, and that's a little bit strange because xy is a monomial. It's one thing, kind of the opposite of what we were doing with polynomials. If I had like 2x squared plus 3x plus 4. This is a monomial. That's a monomial. That's a monomial. So it's one chunk, but there are 2 different powers associated here. We've got x, which has an implied power of 1, and we've got y, also with an implied power of 1. So when I power up, I have to distribute that power of m or multiply it to both of those. So that would give us x to the m, y to the m. So let's see what that looks like with an example. Let's say I have 3x cubed squared. Now, from a PEMDA standpoint, I would start inside the parentheses. Can I simplify 3 times x cubed any further? Nope, 3x cubed is just 3x cubed. So our next operation is moving to the exponent. Now, it is in parentheses or outside of the parentheses, so I am powering up, which means I am going to have to multiply each of those exponents by 2. So how many exponents do I have in that parenthesis? 2. We've got the 3, and then the 3's implied power of 1. So I distribute that 2, or multiply that 2 to both of them, which gives me 3 squared x to the 6. What is 3 squared? It's 9. You're going to have bad days where you say that 3 squared is 6. That's okay. It's just a really common mistake, so something to be on the lookout for. We're just multiplying, adding, and subtracting, but it's really easy to kind of lose your head and accidentally say that 3 times 3 is 6 instead of the 9 it should be. So 9, x to the 6 would be our final answer there. So when we multiply the bases, we add. When we're dividing the bases, we subtract the exponents. And when we power up, we multiply the exponents. So let's go ahead and go down to this one. Can I simplify x over y? So nothing to do inside the parentheses. My base operation is that I am powering up. So how many exponents am I going to need to multiply by that m? 2. We got the x with the power of 1 and y with the power of 1. So I'm going to have to distribute or multiply to both of those. So this is powering up as well. So x to the m over y to the m. Can I simplify that further? Why can't I subtract those exponents? They're not like bases. They don't have the same base, so I can't do any simplifying with those ones. So now we're going to do a little bit of exploring down at the bottom. We're going to try to figure out what 3 squared is. What is 3 squared? 9. What's 3 to the first power? 3. 3 to the 0, we'll wait on that. 3 to the negative 1, and 3 to the negative 2. So we've worked with powers of 2 before, with all the stuff we did with quadratics. Powers of 1, just give us that base. 3 times itself 1 time, it's just 3. But 3 to the 0 and 3 to the negative 2. First, we're going to do the negative ones. 3 to the negative 1. Make a prediction. What do you think it will be? Most of the time, students are like -3. But here's what's unique about negative exponents. 3 to the negative 1 gives me 1/3. So negative exponents don't change the sign at all. Let's try 3 to the negative 2. And folks, to type this in on your calculator, you would do 3, then the caret button, this one right here, and then little -2. And what we find is that 3 to the negative 2 gives me 0.1 repeating. But if I turn that back into a fraction, we see that it's 1/9. With the people sitting around you, tell them your name in case they don't know your name already. See if you can decide on what negative exponents do with these bases. Go.
Well, my name's Duke. I think it's dividing them. So all it's doing is like dividing them apart, dude. I think it's tubular, bro. Is that tubular? Let's go get another 3.
Dude, this is why
Distributing, looking in. Anybody have a good idea out there?
The bottom, like, it's 1 times 3 times 3.
Oh, yeah.
So 1 times 3 times 3 is 1/9. So we look at 3 squared is 9. 3 to the negative squared, if you will, is 1/9. 3 to the first is 3. 3 to the negative 1 is 1/3. So if 3 to the third is 27, what do you think 3 to the negative third will be?
1/27.
1/27 or 1/27. So negative exponents don't do anything to the sign of the number. They do something else. What I want you to write is negative exponents or negative powers are like bad attitudes. Have you ever gotten in a fight with your parents and they say, why don't you go ahead and go upstairs and lose the attitude? Probably during COVID, probably during quarantine stuff. It's like, oh yeah, it's great when the whole house is mad at each other and then you got to try to find different areas to retreat to. So negative powers are like bad attitudes. So we don't want to leave negative powers. Instead, what they do is they change location in the fraction to lose the attitude. To lose the attitude or become positive. So negative powers are like bad attitudes. They change the location in the fraction to lose the attitude. All right, folks, so we're going to go up here where we have x to the negative m. So currently, this is in the numerator or the top of its own fraction house. He's mad. He's upstairs and mad. So we're going to send him to the downstairs to lose the attitude. Now, when I send him downstairs, it becomes 1 over x to the positive m. So by sending it to the other part of the fraction, it becomes positive. So what if I have someone who's mad downstairs? Where do I send them to lose the attitude? Upstairs. So we're going to send this one to the top of the fraction to lose the attitude. So this becomes x to the m over 1 or just x to the m. So when we change its location, it loses the attitude. Now this last one in this row, this is starting to get into combinations of mad spam and my negative exponents. What operation is going on with our bases? Well, we've got division between the x and the y, but they're not the same bases, so we can't do anything. We are powering up, which means we are going to multiply all of the exponents by the one on the outside. So how many exponents do I have on the inside? 2 exponents. So I'm going to distribute that negative m to the x and the negative m to the y. We distribute it to all of the exponents in the parentheses. So now we have x to the negative m, and we've got y to the negative m. So now we got a house full of mad people. 2 mad things going on. We're going to send the x downstairs to lose the attitude, and the y upstairs to lose the attitude. So this will become y to the positive m on the top over x to the positive m on the bottom. The last thing that we're going to talk about is this one, x to the 0, and we're going to introduce that by looking at 3 to the 0. Now, we expected 3 to the negative 1 to be negative 3, and it wasn't. Maybe you're expecting 3 to the 0 to be 0. 3 to the 0 is 1. 0.5 to the 0 is 1. 1,000 to the 0 is 1. The square root of 11 to the 0 is 1. So what do you think x to the 0 is? It's 1. It is always 1. That's my favorite property. Now if you're like, all right, seems fake, but okay. we can actually prove this. I know you guys don't like that word proof though, but we can prove this algebraically using one of our other rules. So if I have x to the third over x to the third, what does that equal? Same thing over itself. 1. But if I use my d to the s part of MADSPAM, this says if I am dividing, we can subtract the exponents. And 3 minus 3 gives me 0, so that is why it is equal to 1. The big trip up for students with this is a lot of times they'll say it's equal to 1x. There's no variable with it. There's no unit attached to it. It is just a straight up 1. So there is a lot of stuff that we just covered. I don't want you to memorize all these rules. I think it's kind of an obnoxious amount of things that we have up here. The key thing is being able to understand how to use MADSPAM to figure out what operation you are doing with those exponents. The only other things you kind of need to have memorized are x to the 0, or anything to the 0 is always 1, and what negative powers do in your expression. So folks, let's just go ahead and jump into our very first problem. If I asked you what the base operation is, that's the capital letters, are we multiplying, dividing, or powering up? What do we think? Powering up, and we have parentheses there. So typically you're going to be able to identify your P as your base operation because it's going to have parentheses. So we are powering up. If I am powering up, what am I going to do with those exponents? Multiply them. So we are going to multiply 2 times 3, and that gives me x to the 6. Boom! Now, if you hit a snag and you're like, ooh, I'm not quite sure what that would be equal to, we can expand this out to get to the same answer. X squared times itself 3 times would look like this. X times x times x times x times x times x. And what we see is that we have x times itself 6 times. So it's not 6x, it's x being multiplied 6 times. Take a look at our next one. What base operation do we have going on between the x's? Multiplying, dividing, or powering up? Multiplying. So we're multiplying the bases, so we will add the exponents. So this is the A part of MADSPAM. So we're multiplying the bases, so we add the exponents. So x to the 12th. Now, as you can see, this is why it's a good idea to have those power rules, because the expansion of this, x times x times x, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's too many. I do not like to expand out with those big numbers, but we could check ourselves that way if necessary. Next, we have x to the negative 3rd times x to the 9th. So we see that that first x has a bad attitude. We could send that to the downstairs like we did up here, but normally I wait until the end to resolve negative exponents unless it is division. So we're actually just going to work with that bad attitude right now and look at what we have going on between the bases. We are multiplying the bases, so we are going to add the exponents. So what happens when I add negative 3 plus 9? We get x to the 6th. Now, that is what I feel is the easiest way to show work on this, but just to show you it wouldn't have been wrong if we did it the other way, I could write this as 1 over x to the cubed. So if I sent that power to the downstairs, which would then lead me to x to the 9th over x cubed. Now I do the bases and subtracting the exponents, and that would give me x to the 6th as well. So folks, on some of these problems, there will be multiple ways of showing the work, My goal is to show you what I think is the easiest way of doing these problems. So normally I work with the negatives unless we have division. Folks, what questions do you have so far with those 3 examples or with the rules? Apparently second block wrote, eat Cheez-Its with ketchup on the backboard. I don't think that sounds good. What do you guys think? Then they got in a big argument about eggs with ketchup. Raise your hand if you're in favor of eggs with ketchup. Yeah, on sandwiches.
Ketchup is actually nasty.
What are you talking
I can't think about ketchup too much.
Eggs with ketchup is like the only
It's like tomato jelly. Ugh, don't think about it.
salsa on a burrito.
That's good.
It's same as ketchup.
Ketchup is thick. I don't know. It's weird. All right, folks. Let's go ahead and take a look at this next one. We are doing what with these bases? What operation is going on between those x's? Dividing. So since we are dividing the bases, that is the D to the S part of Mad Spam. What are we going to do with those powers? Subtract them. So x to the 6 minus 4 gives me x squared. Now, the other way you could think about these problems is kind of just how we simplify regular fractions. I could divide an x to the 4th out of both of those, which would leave me with x squared. So if you want to think about it as taking out a GCF instead, you can do it that way too. So let's go ahead and take a look at our next problem. From a PEMDA standpoint, we would start inside the parentheses. Can I simplify any of that stuff?
No.
No. So nothing to do with the parentheses. So the E part of PEMDA says, let's move to the exponent. What are we going to do with that exponent? Because our bases are being powered up. This is the P to the M part of Mad Spam. So we're powering up, so we are going to multiply by that power of 3. How many powers do I have in that parenthesis? There are 3. So the Y has a power of 1, the X has a power of 1, and that SCSI 2 has a power of 1 as well. So again, shifting from thinking as a monomial as just one thing, a monomial is one thing, but there can be different amounts of powers associated with it. So let's go ahead and power up each of those powers, which will give me y to the 3rd on the top, 2 to the 3rd on the bottom, along with x to the 3rd. So 2 to the 3rd, is it 6 or is it 8? 2 to the 3rd is 2 times 2 times 2. You can check yourself on your calculator, but it would be 8. And it's faster if you're able to do it in your head. So y cubed over 8x cubed. Why are we doing these? The whole point is to simplify, to make the expression look better than what we started with. It's kind of dry, but they start to be kind of fun after a while. This chapter is actually one of my favorites because we start getting into like more stuff with polynomials, so stuff that we sort of just touched on in Unit 3 with the graphs, but this chapter we get into more the algebra side of things, so I think it's a lot more fun. All right, folks, this problem, put a star by it. No, Miss Carol, I won't. This problem is deceptively easy, but there's one thing that throws students off. So that -3, and actually let's just look at a different example for a moment. So folks, if I have 3x squared, like in a quadratic, who's getting that power of 2? The x. Is the 3 getting that power of 2? No, because then it would be 9x squared, and then the 9 would get the power of 2, and then it'd be 81x squared. So what is the power of this 3? 1. So when I look at this expression, who's got the bad attitude? Who do we need to send somewhere else? Just the x. So that 3's like, I'm chilling. I've got a positive power of 1. I'm good. I'll just sit myself right here and stay right where I am. But x to the -3 has to be sent to the downstairs of this fraction to become positive. Part of our simplifying is we never want to leave those bad attitudes or those negative powers. So this is 3 over x to the third. So folks, it'll be important on this section that you're checking your answers carefully with the answer key, making sure everything is in the right position and also has the right power with it. Here's another thing I want to talk about. Let's say I have negative 2x over 3. Why am I not going to move that 2 to the downstairs?
Because of the 3.
Because why? It's not a negative exponent, folks. Negative 2 is just a negative number. So sometimes after students get in the mode of like, oh, I take the negatives and I move them downstairs, that is only for negative powers. Negative numbers are still just negative numbers, so negative 2x over 3, that's simplified. I would not move that 2 to the downstairs. So I would just put a not equal sign here. This is not going to be this. Is not going to be that. So again, you guys would never have done something like this in the last unit, but once we start seeing these power rules, different temptations arise where it's like, wait, should I be moving that negative exponent? All of these rules are just for your powers. So folks, let's go ahead and take a look at this one. X to the 4th over x to the 6th. We are dividing those bases, so what's our power operation? Subtraction. So we have 4 minus 6, and we get x to the negative 2. Will we leave it that way?
Yes. I'm kidding.
Thank you. So we're going to take that bad attitude x, because it has a negative power, send it to the downstairs to resolve that bad attitude, and we get 1 over x squared. If you don't want to use that rule, you actually can just cross simplify by taking a GCF out of the top and the bottom. So I can just take an x4 out of both of those, which will leave me with a 1 on the top and an x squared on the bottom. So I'm fine if you want to cross simplify instead, because you will get the same final answer. All right, folks, I'm going to turn you loose on the next two. See what you can do. All right, folks, we are powering up Matt's band. So we are going to multiply every exponent in parentheses by 4. That means 3 gets multiplied by 4 and 1 gets multiplied by 4. So that's kind of tricky because it's not that 4 is getting multiplied by 4. It's the exponent of 4 gets multiplied. So that's what that exponent m means, that it's only happening to the exponent. So that will give me 4 to the 4th, x to the 12th, and you can use your calculator to figure out that 4 times 4 times 4 times 4 is 256, x to the 12th. Bless you. All right, folks, now, I don't know about you, but this one makes my brain hurt. Why is this so painful to look at? So, if I just went straight for the D to the S and said, hey, these are separated by division, so I'm going to have to subtract those exponents, we would say it's x to the negative 2 minus a negative 5. what's going to happen with that double negative? It becomes a positive, and we get x to the third. Now, I will say that from years and years of teaching Algebra 2 and Pre-Calc, this is the number one mistake that throws students off. Students a lot of times say that this is x to the negative 7th. So my recommendation is actually to not do it this way, but to resolve the negatives first. So this is that little rule that we wrote up here about resolving our negatives first. Instead of trying to work these negatives, I'm going to send him downstairs to lose the attitude. I'm going to send him upstairs to lose the attitude. And now that I have x to the 5th over x squared, isn't it a lot easier to take 5 minus 2 than negative 2 minus a negative 5? It's way easier. So this will give me x to the 3rd. So we get the same answer, so I don't really care which way you want to do it, but I will say that I see a lot less mistakes with resolving the negatives first with dividing so that you don't get those double negatives. I think we'll go ahead and we'll see what's on the next page. Let's see what you guys can do with the next 2 problems. Actually, next 3. Struggle with those 3 problems until we break for lunch.